Thank you very much. Hello, everybody. I'm here calling in from Binningen, close to Basel, from my home office. As I guess many of you know, that kind of thing at the moment, everybody wants to do home office. Me too. And it actually works great. I just learned about this OBS studio to mix everything together and stream it on YouTube. That's a really cool thing. We'll use it for our meetup too, for sure. So I want to talk with you about Kubernetes continuous integration and delivery training for developers. And this is a great intro we just got with the talk. So we already heard like a lot of nice introduction and insights about what's important and the challenges that a lot of developers face. And we thought about doing a training for that. We already had kind of a more system engineer-like training before with some kind of like basic Kubernetes introduction and playing around with some things. And I visited a lot of trainings with Kubernetes and Docker Swarm in the past, and often it's interesting, but usually it's pretty hard to get kind of like a nice setup running. So let's just make a quick introduction. We're from Letsboot. We started in 2016. We do trainings about technology that we really like. So we're a group of freelancers and consultants doing all kind of topics, in-house trainings, public trainings, and one topic is now also Kubernetes and containers. So let's go straight away to the goal. We wanted to build a training where we show software engineers how to build and manage images and containers. That's one of the main things that you have to do as a software engineer when you start to use containers and Kubernetes, is you have to bring your application into a container, then to configure kind of the setup you want to run on Kubernetes. So kind of like how the application parts, as we've seen before, there are many moving parts, how they have to work together, how they have to be started. And then the most important part in our view is to automate everything. And that's something we missed in many trainings, is that you had amazing insight in containers and Kubernetes and some specific cloud technology, some Google Cloud, AWS, whatever they were showing. But this kind of like round package of having everything automated and continuously building the containers when a developer changes something and then delivering it on production and stage environments. This is something which is pretty hard to set up, and that's why you rarely have trainings where you actually can do that. And then of course we needed kind of like a more or less realistic. You cannot do a full realistic app because then you have a lot of like things you don't really need for the training, but like an application which is kind of realistic. Everybody can quickly understand what the application does, because you have developers with different kind of backgrounds and especially diverse applications. So an application that has a certain amount of cases that you can show, not just like a back-end, front-end database thing, but something that has to do something somewhere more than just showing data, which most applications do. I mean, as soon as you send emails or whatever, you will have this kind of situation. And then also the setup around it. So like having a real complete setup, like if you're a new developer, you're joining a company and they already have like an application running on a cluster and everything you need to basically start to put a new application into containers and do everything hands-on. So our trainings are always hands-on. Mostly it's even a bit more than 50% is exercises with us trainers helping and explaining in between steps. So quickly, I want to do a very, very short overview about the main topics for everybody of you who maybe don't know it. So bear with me here a bit. Let's first talk about containers and software developers, because we are talking about software developers and not system engineers, because system engineers have a very different kind of thinking of the world, and then software developers, and both have their own right to do that because they have different tasks to do. So when we go back in history and we wanted to run application, that's basically what we want to do. We want to build and we want to especially run applications. We put applications directly on bare metal on servers. There's still some cases people do that, and that means we install different applications on a server, or we install applications on different servers. So they are really strongly connected to the server. And then we need dependencies. So to run an application, you usually need some libraries, services, whatever configuration in special versions, so this application feels happy. And below that, you have an operating system like mostly Linux or Windows, where those applications and dependencies run on, and the operating system basically manages CPU, memory, storage, and network. So this was basically the case to do things for a long time, but it already changed many years ago. I think most of you from the audience know that most things today run virtualized. So this first step is important to understand containers. So why did we not continue to put everything on bare metal? Why did we start to virtualize and put operating systems in virtual machines, which kind of give them a separate server with their own resources? So one of the main reasons is utilization. So the first thing is you have faster, bigger servers, and you have different applications using different amounts of resources. One application needs a lot of memory and CPU, the other one not. And so with virtualization, you can put multiple operating systems with their own dependencies and configurations on the same server, and they're pretty much separated. So if the system engineer updates operating system, he can talk to the developer and do that only for the first virtual machine with the first application. And if one application or one server, virtual server, uses too much memory or too much CPU, it shouldn't harm the other one. So this is kind of one of the first things. So to separate and to optimize the utilization. But as you may see, virtualization has added some things. So if we look at the bare metal machine, we just have the operating system managing CPU, memory, storage, and networking. So between each application, basically separating those and making sure that everybody gets enough. If you go to virtualization, you have this more or less 3 times. You have the host system, you have the virtualization, and you have the virtual machines doing that. You could argue that you can do virtualization to a point, optimize it to a point that it's close to containers we're coming to now, but in the end, you're still like having an operating system running for each virtual machine. And then you have the third case, which is the container case. So what happened between virtualization and containerization? About 15 years ago, maybe even a bit longer ago, they said like, okay, why do we need to have a complete operating system and a complete separate management of CPU, memory, storage, networking, and everything to separate our applications, to make sure that they don't influence each other for security reasons, for performance reasons, and also to give the system administrator and the developers a bit more flexibility in updating their systems. So this is kind of like the question, why do we do that with virtualization? Because the operating system is already able to kind of like separate those things. So Google mostly started to integrate features to enable the operating system to do that, and said like, okay, we don't want to actually run complete separate virtual machines. We can actually tell the operating system how to do this kind of separation, so the application developers are happy and their applications are happily separated and don't influence each other. That's kind of like the jump from virtual machines to containers. So technically, if we talk about containers, we're actually really just talking about applications running directly on an operating system, which is in most cases Linux. And the operating system actually learned to give all the separations we like about virtual machines. So you have dependencies for an application which you can update with separate configuration. You have separation of all these resources, and you can also use the same physical server for multiple applications by putting that into containers. So a container at the end is just the application and its dependencies, and the operating system learned how to manage this in a way that those different applications run in their kind of like abstract idea of being a container. So they actually feel that they're on a separate server and they have all their separate resources. And then you have a little piece of software, a container runtime, which helps the operating system actually manage that container. So this is just like a very short abstract about that. But what I would really like to say about this is actually not the technical part, but more like the way how to think about how this evolution happened. Because the biggest difference actually between virtualization and containerization is actually who's managing what. If we're working with virtualization, mostly we still have the idea of the system administrator setting up servers for applications. So they, of course, have this host system where the virtual machines run on, and then they set up the virtual servers, automated or manually, whatever, but they set them up for a certain kind of application. So here you have still the system administrators often kind of with their thinking setting up a server for a certain kind of application. And then you have the developers putting their applications onto those servers, and then there are these points where they get together and have to argue about why it's working on the developer's machine and not on the production machine. This is kind of like the main difference. And with containers, this completely switches. The system administrator has one main goal. The system administrator or the provider of the environment has the goal to provide a good cluster to run containers on, or to provide an environment to run those containers on. And the containers are kind of standardized. So as long as this environment is able to run those standardized containers very well, the system administrator knows that he or she is doing their job well. And on the other side, the developer is now not only deploying applications, but the developer is actually deploying applications with their environment. So this is for me the biggest change with containers. It's not necessarily the technical part about how it's optimized and how you can run 1,000 containers on a server where you couldn't run 1,000 virtual machines. That's kind of a nice thing, but the main thing I think is that developers now deploy containers which contain the application and the environment. So the developer doesn't argue with the server system engineer about the dependencies. He argues about, he just wants to have a nice cluster environment for their containers, and he has to, or she has to provide a container with the application and the dependencies. So this is kind of the main thing to get a quick overview. Okay, so the next thing I want to talk about is Kubernetes. So if you imagine you have those containers now, the software engineers, they build those containers, and in the container is the application and all the versions they want. Maybe one part of the application they want to develop with Java, one part of the application they want to develop with Python, then they have an older part which they want to run with something else because it's working well with that. And the developer can now put everything in the containers that the way he wants it, and rolls out those containers on some kind of cluster or server where those containers run. This is kind of the main idea. But now you have to kind of like manage those containers, because the container itself has just an application and an environment of the application and an information about how to run this application. And for that, you actually need Kubernetes. So I just picked a few slides from our course. Of course, we have many more, but just to maybe get a quick idea. So basically, if you imagine those are servers, and the software developers want their applications on those servers in a certain way, and they want them to be able to talk to each other in a certain way. Maybe you have a back end, you have some front end, you have some services sending some emails, you have a database, and so on. So there are different parts of your application you want to put on a server as containers and run them on a server. And so they need to be updated, restarted, and monitored if they work, or if they don't work, they have to be restarted, or if they're getting too slow. Maybe they have to be scaled up if there is a lot of demand. And for that, you need Kubernetes. So if you have containers and you have your application running in containers, you need something to actually manage those containers. And this is kind of an additional abstraction layer. So for the developer, first you put your application with your environment in the containers. That's kind of the main thing. And then you have to think about, okay, how do those containers have to run on the servers? And you have to write that. And for that, you write configuration. So you write code. So from now on, you're not going there to say, okay, now I put this application on the server. No, you write the configuration, how your application should run on the servers. And then you tell the Kubernetes server basically, hey, I want to run this way. And then the whole application is started with all its parts and is run on the server. So this is what you need Kubernetes for. So this is the second major part of our training, and the major part that basically developers have to learn to migrate to use containers for their application. Okay, so the third part is continuous integration and delivery. And you already see, like, there are a lot of parts. Even if you're a good software engineer, if you did never see like containers or Kubernetes or CI/CD, most developers know already CI/CD, but still it's like a lot of things. But from our point of view, you really need to put that in a nice package if you really want to start using containers on Kubernetes. So the next point is continuous integration and delivery. What does that mean? So the developers write code. That's kind of the main thing. What's new is they also write their environment. So beforehand, you come to a company, you know they use JBoss, they use Java, this version, that's the life you have to live, that's what you have to work with. And then you had basically to write your codes in the way that it was working on those servers, the way that your company told you to do. This has advantages and disadvantages. So you're less flexible. You have more to talk. You have to talk more with your system administrators, and you have more of these effects of it's running on my machine, but not on the server. So what developers do now, and that's basically, I think that's mostly an advantage for the system administrator or the cloud provider, that the cloud provider can say, okay, dear developer, if you need that special environment with that version for your application to run, just tell me how it should look. Write it for me, like write the container how it should look, write the environment, and then put it into a standardized container, and I will run it smoothly. But you can choose how and what kind of versions you want to use. So the developers now also have to write their environments. This adds some layers of complexity to their thinking, but it's also a big advantage because now the developers also have the responsibility to take care of the environment. And especially they have and can test the environment on their own machines. That's kind of one of the most important things. They know if the container runs on their machine, at least now if we talk environment, the container, one single container, they should know this container should run the same on the production server. If you don't think about external dependencies, like inside dependencies. So they write environments, they build containers out of that. So the application is part of the container with the environment, and they can run it like on production. So they can run it on their local machine the way it will run on production or tests. Then they put their code on some Git repository. So basically they have a central place where they put their source code, where they manage the code and see who changed something, and they can argue about code. They can say, okay, I want to check in that code. Can somebody test it? And somebody can say, okay, we accept that code, and so on. There are many things about this version control. So this is kind of the thing on the developer side. And now you put this together into this Git repository, which is the central place where we manage the software. This is kind of the technology that I think nearly everybody uses Git now. And now the continuous integration and delivery starts. So what we want is we want developers to commit their changes as often as possible, because the worst things that happen in projects is basically that developers work for several weeks on their own on some version, and then other developers try to use it, or the testing team try to use it, or they try to merge it with their own changes, and then it doesn't work because they changed many things here and they changed many things there. So you have this kind of like long periods of putting everything together again. So this is kind of the main thing about continuous integration. So basically what you say is, okay, developers, please push your changes very often as possible, and now also to the environment. So if one developer decides this part of the application has to run in a new version of the environment, everybody else will see, okay, now I have the same environment, and they will not have a problem 2 weeks later when they put their changes together on production. So continuous integration does the following: whenever somebody puts a change on the central repository, which they should now do very often, like 2 times a day, 3 times a day, or whenever basically they have a meaningful change, which makes sense for the others to watch, which works in itself. And if the change is too big, they should anyway work a bit different, but that's another topic. And now, as soon as they put it on the server, on the central Git repository, the continuous integration automation starts to put everything together. So they basically compile the software, and they run some testing, and there are many steps you can put into this to make sure that the change that the developer put on the central repository works now, and that there is no like surprise 2 weeks later that somebody checked something in that actually doesn't work. But what's now actually new about this thing with containers is that you're not just building software now, but you're actually building the container. So instead of just having the application without the environment, you actually have the complete environment with the application. So that means if the developer committed, let's say, a PHP script, which you usually don't compile, with a certain PHP version and some specific module in addition that he wanted to use or she wanted to use, then the environment with the code gets built and gets tested together. So the CI actually really uses this PHP version that the developer decided to use, and then you will actually see if it works together. And now there comes the delivery part. So we solved the problem that developers put their changes together and they get built and tested. So quickly, you know, if a developer puts something in the repository for the others, which doesn't work. So quickly the developer sees, okay, my change didn't work. I have to go back and fix it again. So the next step is you want to put it on some server. And that's really important if you move to Kubernetes and containers. This is something you have to automate. And there are so many companies still that don't automate this delivery part in current applications. There are so many cases where companies still like build their Java var file and put it with some file transfer on some server. So you need the delivery part. And the delivery part basically means that you have this built container, which is basically just a package containing the application and the environment. And this package, this container, has to be put on some registry or some repository place where it can be pulled from. And then you have to tell basically the cluster, hey, get me this package with this version to run it on production. So basically the continuous delivery part allows you to automatically put every change, if everything works out, to, let's say, a test or a stage environment, and then depending on how you decide in your project to work, to put it then automatically on production. With the final goal that developers can make often many small changes, that they're integrated with all other changes very quickly, and that they can be put on production very quickly. This is kind of like one of the most important things where containers can help you. And in my sense, also Kubernetes can help you a bit to make this better and simpler. Okay, so let's continue back to the topic we want to talk about. So what we know from other trainings, because we usually do trainings for software developers with coding projects. So over the last 4 years, what we developed as a process is we usually have an incremental course project, which is source code. So you can imagine you have some web application with Angular, you start with a view button, a list, and then during 2 or 3 days, you build those with chapters, you build this application to have, let's say, a web shop at the end. So you have this little kind of changes. You always know what kind of code changed. We can present you the material. You can do the exercise, and you always have the solution code. So you can basically walk through it, walk backwards, and actually see what's happening on your machine. The second thing we learned in the last 4 years, which is really amazing, is we have this this thing that everything is code for us. So we say infrastructure is code, and software is code, but also course material is code. So what we do is we have slides which are markdown files, so developers can easily change them, the different trainers. We have the exercises which are directly based on that. We have every step of the course as source code steps, which you can easily switch between the steps. So you know if you did something wrong or if you fail, you can basically just switch to the next chapter, and then you can work through it again. So you have a fast-paced training, and everybody gets through the training without falling off if there is some technical issues. And also we have a automated testing. Because with all those technologies, they change so often that we have to update them like every 2 months. I mean, basically before each training, we have to update them. And that means we have like a lot of chapters sometimes. I mean, for Angular, we have about 40 chapters, depending on how long the course is. So we have to test it automatically. And then you have the participants with a local setup so they can develop and run. And that's pretty easy with code. So if you have a source code project, if you have a software developer training for source code, you usually don't have a very complex setup. They take some Visual Studio Code, they install some build tools, and then they can start to work with Angular or whatever. Now we have Scala or Akka or whatever, you can do that. But now with Kubernetes, it gets a bit more complicated, because what we really need now to show everything we want to show is we need the local tools to run and build containers. We need the local clusters because we want the developers to be able to run everything local as it will run on the cloud, or on their own cluster. Then you need a Git project for each participant. If you do a software training, it's not that big of a problem because everybody can use the same Git. But if you do a training for software engineers to do Kubernetes, then everybody needs their own project because they want to have their own CI/CD pipeline. So they have to be able to kind of like see if they change something at the continuous integration delivery part, if it works or not. If they do an exercise, let's say to add a separate environment, so they have some test environment where everything gets deployed for the testing team in your company, then they can easily test that for their own pipeline without disturbing the other participants. They need a private container registry to have their containers. And they need a cluster, an actual production cluster. So basically, they don't only have the local developer cluster like you most of the time have, but they really have a cluster in the Google Cloud, so they can see and use and try all those kind of features you usually only can see in an actual cloud cluster or in a bigger cluster with auto scaling of nodes. And there's so many things you can, and then example application scenario. So the challenge here is there are many moving parts, there are many tools and versions, and we didn't want to have the participants to use any credit card or need any cloud account, because it's possible. It's not that it's not possible to do, but it's kind of like scary if they have to create their own Google Cloud accounts with credit cards, and even if it's free at the beginning, and then do the training setup. If they mess up, suddenly they have a lot of costs, or maybe they don't like Google Cloud and they don't want to do that for the training now. And also for us, it's harder to kind of see what the participants do. So we said everything has to run on our cloud infrastructure. So the next step was authentication. That's kind of the hardest part in this thing. It's kind of like getting everything to work with each other. There's a lot of security in the internet and in those topics, and that makes it really hard to set up everything. And that's the main next point. You don't want to do a 3-day training where the first day is just set up, because those are software developers that like with the project we saw before, they come into a team, they want to develop software in a container world, in a Kubernetes world, and they want to learn that part. They don't want to spend one day or half a day just to set up everything that the way we think it should be set up. Because with the company they work, they usually have a different kind of setup for all these kind of tools and clusters that we need to train that. And especially the main thing we saw in trainings is that there's not on my machine problems. That's something you still get with containers if everybody sets up their own thing and somebody has this version and somebody has this version. And this is something you can do during the training. So if somebody with Windows has a different problem than somebody with Linux, that's just something that kills the training if you have to help. Because there's some permission problem from the operating system, and then you're basically helping one person, and that's something we really didn't want with that training. So what was our goal, or what was our solution? We said, okay, we need an application that everybody can kind of think about and easily understand. So we decided we do a web crawler, like an application that basically archives websites, and you can see the pages it found, and it stores the pages in a database with the meta information and the files, and you can list the pages that were found, and you have a crawler and so on. So the reason why we chose that is so you have the different parts which you can run on Kubernetes. Because if you just have an application with backend and front end, it's kind of boring. You won't see all the effects that you need on a cluster to learn what you need to think about as a developer. So we have a front end, we have a back end, we have some kind of service running in the background, or multiple services that do the crawling, and we have another service which does the scheduling. So these are parts of our application. And then we have a database. We chose Postgres, but it doesn't really matter. And we have a queue, as we saw before. That's kind of a thing most applications use today. So you have one database for like persisting the data long term. It's very reliable. And then you have another database which is basically specialized in managing kind of tasks or messages with applications that listen to these lists or tasks, and applications that put tasks on this queue. So these are parts that your developers usually meet when they start to work with containers. And then we want to bring everybody through this line of work, like how would you containerize an application and put the application into a cluster. And to do that, we show how to build containers, how to run them locally. So you really see like how it will be run automatically on the server, each container by container, how to put it into a central place so other developers and the cluster can get it, and how to configure the deployment. So Kubernetes knows how to run it, and then actually putting it onto a production cluster, which is kind of a short thing, but it's kind of an aha moment. So you build everything. Here it starts pretty slowly, it gets faster and faster. Everything is configuration. And then at some point it's like, okay, now we put everything on a production cluster at Google, and it's like, bam, okay, that's why we need to automate everything. That's why we need to basically write everything as code. Because if you have it as code, this part gets very easy. So at the end, if we build all these steps, and we went through that steps, and every developer was able to play through that, you can basically just move all the steps you did, more or less, the configuration, into your automation. So the automation gets really, really easy at the end. And sometimes developers are like at the end, like, okay, that was the CI/CD part, and I'm like, yes, because most of the things we already did. And that's really important. So if you have a software team to start with containers, start with CI/CD. If you start to do everything manually, it's very painful, and it's harder to do it afterwards. If you start with CI/CD, with the automation from the beginning, you will actually have much more benefits from everything. Okay, good. So what was the solution? The solution was that we said, okay, we will not be able to get that running in, like, let's say two days without wasting the participants' time with SSH keys and authentication files. And this person already has that account, and this person has already this on their machine. So we said we have to put everything into the cloud. We have to put the complete development environment in the cloud, so we can start like 10 environments for 10 participants with all these moving parts that we need. And we know we have a consistent environment that every developer sees. And that's also how it should be if you join a company. That a developer can quickly get the complete environment, how everybody should work. This environment should be the same for everybody, and then they can quickly work with all the parts, with all the moving parts from the company. Of course, then you wouldn't do that here, you would put it here directly. So what we said is, okay, let's do a web developer environment, and thanks to Visual Studio Code, or the project we use is called Theia, you get an amazingly fast and comfortable web development environment on a Linux machine, which we run on Google. And every participant gets one of those machines, which is completely pre-configured for everything. So you can run commands on those and the machine. You have the local container tools on the machine. You have local Kubernetes cluster on the machine. You can write all the config files, and you have all the course material. You get your own GitLab repository with your own CI/CD pipeline, where you can basically see the continuous integration, and you can do everything from your browser. So you don't have to do all the setup on your machine, and you can immediately start from the beginning. This we automated with all the APIs. That's something I can show you just in a moment. And then we have the production Google Kubernetes engine cluster, where you can at the end roll out everything, because with the CI/CD, you need somewhere to put it. You don't want to put it on your local machine. Okay, so I will now go into the demo and what we built. So when we have a training with maximum 10 participants, usually we just spin up a script which creates us 10 machines and does a lot of configuration. And this looks like this. So here we have a developer machine, which is this Google Cloud instance. And the Google Cloud instance has all the local developer tools needed to build the training, and has already all the authentication, and has already all the chapters from the training. So if I, for example, have slides here, the participant can easily go here, open the slides as code, and sees all the steps we explain. So this is a Git repository. This is markdown files, which gets visualized in the slides, and there they can work through the training here. We have a complete environment with Docker. So we have here Docker images locally running. We have Kubernetes. We have here two environments. We have a Google environment. We have a local kind environment, which is kind of a local development environment for Kubernetes. And we have a lot of chapters we can walk through, even some custom chapters like for Java developers. Depending on the training, we basically combine all the chapters, which is amazingly easy if it's Git, because if it's source code, because you can remove a chapter, you can add a chapter, and so on. And then we have our famous project here, where most of the trainings happens. So here we have the files, the Docker files that people use to run the application. We have all the configuration for Kubernetes here, and everything is code again. So it's the way we work with trainings. We're used to, people can step through a very complex environment and get that. And then the next thing is we have the GitLab repository. We chose GitLab. We try to keep the training as unopinionated as possible. So we show everything as command line tools, because we recommend that everybody learns everything first with the command line. But with CI/CD, you somehow have to choose. And with the cluster, you also somehow have to choose. So we chose GitLab because everything is in there. You have all the material. Everything is code again. You can open the slides. You see everything. You can walk through it, and everything is automated. You have your container registry, where developers can push their containers to then run them on the cluster, and everybody gets their own CI/CD pipeline to run everything. And I can tear down and pull down this kind of environment with a few minutes, like okay, maybe 20 minutes, because the cluster starts not that fast with Google. But that's kind of like what we do. And then you have your application locally. It's not a web training, it's a cluster training. So basically you have here an application with all the running parts on your local machine and on your Google cluster. So this is kind of like the outcome of the whole thing we built, which allows you to do all these complex parts in a very short time without having to tell the participants, okay, this part would work like that, but we can't show you because you only have a local cluster. Or this part would work like that, but we can't show you because you don't have node scaling. And this way you have this kind of big complex system for every participant, and you can really easily reset it, and everybody can walk through that pretty quickly. Okay, that's so far. I have to speed up a little bit. So how we did that, mostly Carlo, we automated that. At the moment, we did most of the things with the API from GitLab and Google Cloud. So Google Cloud is an amazing API. So we automate everything. We automate the training material, we automate the setup for the machines, and we automate everything in the course because that's what we teach. So we use the GitLab API, which is amazing. We use the Google Cloud API. The training doesn't show much about Google Cloud, but still Google Cloud is amazing for us to quickly start up 20 clusters, to quickly start up 10 developer machines. So we have quickly with 2 trainers, we have like, I don't know, 48 machines running for 2 or 3 days, which is actually not that expensive if it's just 2 or 3 days. And then we install all the tools and we configure everything. That's basically what we automate using these kind of APIs, putting everything together again so that the participants don't have to create logins and don't have to do all this kind of authentication parts. Exactly. So the next step we want to do with this walled environment is we want to migrate everything to Terraform. So that's kind of like how you usually end up at the beginning. You do stuff with commands and shell scripts, and you kind of have to learn how to put everything together, and then you migrate to a next tool, which then helps you again much more to do that. Because the infrastructure as code is a new thing for us. The CI/CD we already do like for many years, but the infrastructure as code is a new thing. So we learned a lot with that, building up the scripts to build that. And then the next thing we will do is put that in Terraform and Ansible, because it gives, or Ansible, that gives you much more overview what happens. And we will do more modules and advanced parts, show like stateful sets and so on, and show them a possibility to install their own clusters and so on. So this is kind of our message, is to automate everything. And if you can't automate it, you're doing it wrong. Of course, at the beginning, you have to start somewhere, and there are always parts you can't automate. But in our point of view, if you can't automate it, you usually have a very red flag that this is a part that will bite you in the foot in some weeks. Yeah, exactly. So what we really can recommend if you want to start with Kubernetes, especially as a software team, is first also start with automation. Don't just learn Kubernetes if you really want to use it. And if you want to get a first quick glimpse, we can really recommend the 9 Academy Kubernetes training. So if you want to go at a place, and this is not a training from us, but it's also amazing to get 1 day, like quick introduction to Kubernetes, hands-on with Google Cloud, go here. And if you want to have the more in-depth training with all the automation parts, we have this kind of extended training, which we can also adapt to different kinds of clusters and stuff. So that's it. Now let's look at your question. I didn't look into the chat, so I'm not really sure if I bored everybody out of the video. Okay.
So thank you very much, Jonas. We have some questions. So Dan and Daniel started talking, so I hope I find out what really the questions are. So one is a comment, I guess, from Dan. It says, is it true that containers make DevOps practice easier, but with tools like Vagrant, it is possible to achieve the same separation of responsibilities between ops and dev without changing technologies?
Yes, it's not like that. It's so let's first start for everybody. Vagrant is a tool where you basically can do something very similar with virtual machines. So with Vagrant, you basically can automate the build up of virtual machines, and then developers can usually, the way I know it is that developers usually use Vagrant to quickly set up an environment on their local machine, and then basically run the application on this virtual server locally. And if everything is nicely done, it's the same on the production machine. Yes, of course, if your application does not need the additional things you get from Kubernetes and containers, if it's like a big monolith and you don't need much scaling, or you can do it with vertical scaling, like more RAM, more CPU, and not like much more, but let's say, I don't know, 16 CPUs, 64 gigabytes of RAM, and you're super happy with that and it works forever. And then maybe containers and Kubernetes is not necessary. But what I often see actually with Vagrant and stuff is that developers use it on the machines, but on production it's still a bit different. So you still maybe don't have the exactly same machines. But yes, if you don't need an additional features, if you don't have a lot of containers to scale, or if your application is not running well in containers, you have to really think about it if it's worth it. It doesn't make sense to drive to the Coop with an airplane. That's true. Yeah.
Okay, thanks. Next question is, how much effort is it to write automation code versus to code the actual product?
At the beginning, it's a bit. I think at the beginning, it's a lot of finding out for the automation. So let's not talk about end-to-end testing and unit testing, because with unit testing and end-to-end testing, you write automation for each feature you build. So that's something that grows with your application. But the automation for the delivery and the integration, that's actually not too much work to maintain. At the beginning, you kind of have to find out how to do it right so it works for your application. But as soon as it works, you will not change that much. And the most important thing is that's the most important thing. You have to solve all those things now too. The only difference now is that some guy in your company somewhere at 5:30, because management says don't do it before 5:30, some guy in your company 5:30, 9:30, whatever, or at Saturday is doing some commands and is hoping it works, and on Sunday evening maybe it worked. And there is a lot of hidden knowledge in doing stuff manually. So often it feels maybe easier to do it manually because I know how to do it, but I can't really explain it. And if you automate it, you get this kind of pain of like, okay, I know how to do it, but now I have to really know how to do it. So the things I quickly do, and I quickly Google, oh, what was this key again, and how does it work again? Now you have to really think about, okay, I have to do that like this, and then you can automate it. So I think it's not much more effort. I think you will save so much more time if you have a good continuous integration delivery, as if you don't. It's so much more time you will save just because arguing about problems you have on this system which that developer doesn't have on their system. There is so much waste of time. Or this developer is in vacation, and if he does deployment, he remembers to run the database migration, and this developer doesn't know it. So if he does the live deployment, it doesn't get run. Yeah. So usually I think it's a plus. You will save much more time developing your software if you automate as much as you can, and especially if you also treat your environment as code. Provable, like reliable code you can check, like what did he change? Okay, he changed from PHP 7 whatever to PHP 7 whatever, or from Java X to Y, and now it doesn't work again. So let's go back. And if you do this manually, it's a bit harder to know what happened. Yeah.
Okay, thank you very much, Jonas. So we switch back to Zurich. So I changed the micro. And I hope this one works now properly with the right screen. Thank you very much for watching, and sorry again for our problems at the beginning. It was a very simple problem. I changed some setting at the last meetup that the stream do not automatically start. So I just had to hit the start button at YouTube, and then it worked. So thanks. So I would be happy to see you again at the next meetup, and don't forget to subscribe our YouTube channel. Thank you very much, and bye.